Welcome to today's expert webinar or expert workshop webinar. We will talk about SIPROTEC fault recording in the digital substation, and you will learn how to implement an independent judge to your power system. The information is designed for substation automation, for substation protection, and for maintenance engineers. My name is Michaela Mönikes, and I'm happy to be your guide through this webinar. If we have online or not on, you can meet me in presence or virtually, guiding tours around the Siemens booth and guiding you through this webinar. Within today's webinar on SIPROTEC fault recording in the digital substation, we will start with an overview of the 7KE85 fault recorder. You will learn about the additional applications available in this multifunction device. You will learn how to create a device configuration with DIXI5 in just a few steps. You will get to know the integration with process bus, digital substation, and a wide area monitoring system. And you will see a live C-graph for sampled measured values and additional applications. One of the questions we receive rather often will be answered right now. Yes, we will record this webinar. And yes, you will get access to the recording and to the slides that are presented during the webinar. If you already joined one of our last energy automation webinars, you know the question and answers functionality, or in this case, kind of the questions functionality. You could type in your questions into the questions tool, and after the presentation, I will be your voice and ask the questions to the experts. Another possibility, in addition to that, we have the chat functionality today open for you. Everybody can read what's in the chat, and we have an expert in the background to answer short questions in there. I'm seeing there somebody hearing no sound. I think the rest of you is hopefully quite okay because it looks fine on this end. Try an F5 and refresh there. Sasha, eventually you can type that in the chat as a help for those people. They can refresh the browser, just take Chrome. I think it's something like Command on a Mac. We have one limitation for question and answers and for the chat functionality. Questions can be read by us speakers, by all the presenters, and the chat area can be read by everybody. And questions that will not be answered during the presentation because it might be too many, they will be answered afterwards via mail. And just in case you are in full screen mode, press Escape, then the area around is visible. But now let me introduce our experts for today for this workshop. We have José Malagon with us. He is the promoter for topics related with the digital substation. And with his extensive dedication to power system stability, José will present his expert know-how. We also have with us today Markus Kraft. He is an electrical engineering technician in information technology and a VDE certified power quality expert. With many years of experience as an R&D project manager for the power quality evaluation software CCAM PQS and CCAM PQ Analyzer, Markus consults customer by designing individual grid code evaluation concepts, and he will present some interesting details. And we have Sasha Desnitzer with us. He's the product manager for the SIPROTEC-5 platform and responsible for the C-graph fault analyzer software. With his expertise in fault analysis, Sasha will be our expert in the background and answer your questions in the chat. José and Markus, we are curious to learn about the SIPROTEC fault recording in the substation. So please go ahead. Let's dive into this hands-on session on how to implement this independent judge into your power system. The two of you, this stage is yours.
Thanks, Michaela. Good morning, everyone, and good afternoon in the other region of the world. My name is Jose Malagon. I'm working here with topics related with power system stability. And today I will introduce you in the fault recording application with 7key85 and how to implement the 7key85 in the digital station world. Let's go to start with the table of content. Let's going to start first with the introduction of the fault recorder 7key85. Then we are going to see what are the fault recording functions, what are the application, or what functions we have also related with the phasor measurement unit with the 7key85. Then later on with Marcus, we are going to learn about power quality function. Marcus is going to show us how to parameterize the power quality application, power quality recording in 7key85 using Dixie-5. Then I will explain how to integrate the 7key85 in the digital station using process bus. I will show also how to configure the 7key85 in process bus. At the end, the benefits, and you will see our contacts at the end. I'm going to start with the introduction of the 7key85. It's one device with 3 big applications. I will say for the monitoring topic is all in one: fault recorder, power quality, and phasor measurement unit, all in one device in the 7key85. Where is located the 7key85 in our portfolio? Basically, here we have the protection applications. You know, we have the SIPROTEC-5 for all the applications in the protection, and the 7key85 cover the phasor measurement unit, the fault recording application, and the power quality recording. With this device, we are able to supervise the quality of the supply of the energy and also the quality of the voltage in our power system. Related with the supply of the quality of the voltage, for example, or the power, then we have the application related with PMU and fault recording, where we can see the different phenomena that we have in the power system related, for example, with power system stability or related with faults in the power system. With these two applications, we can evaluate faults in our system or phenomena in the system. In the power quality, we have the voltage quality, and with our device, the 7key85, is able to also evaluate the power quality topic. With Marcus, we will see in deep the topic related with power quality. Then this is our 7key85. It's the fault recorder, the power quality device, and the PMU. In which verticals we can set up or we can use our 7key85. That means we can use in generation, in transmission, in distribution, or even in industry, we can install the 7key85. With different applications, we have the event-based recorder, we have the continuous recorder, we have the power quality recording class S, the sequence of events, and of course the phasor measurement unit. The 7key85 fits perfectly in the SIPROTEC-5 family. If you know the SIPROTEC-5 family, it's a family which the main topic is the flexibility, or the main advantage is the flexibility. We have the option to select the base module with the main functions. Then we have the option to select expansion modules with analog inputs or binary inputs or binary outputs. Then also the communication modules. Once that we select all these 3 topics, that means the base module, the expansion modules, and the communication modules, we have an individual device that is called this SIPROTEC-5 device, expandable device, and we have the 7key85, of course. From the point of view of communication, the SIPROTEC-5, the 7key85, is a fault recorder also designed for communication. We have different applications, different communication applications like 61850, 61850-9-2, that is the protocol for process bus. We have the C37118 to stream the PMU data. We have also in one Ethernet card the 61850 and C37118. That is one of the advantages. And the other topic that is now really important is the time synchronization for digital station. And then with the 7key85 also we have the IEEE 1588 for time synchronization, high accurate time synchronization for PMU and also for process bus. Also, the SIPROTEC-5 device is a device that is designed to offer safety and security inside of the installation. Then we have created a concept related with security and also with safety for the people. Then we have related with security role-based access control that is coming in all our devices and also in the 7key85. The hardware is very robust and a sophisticated hardware. And also with a method to identify problems inside of the hardware. That is really important because the SIPROTEC-5 has a self-monitoring routines that allows us to know what is the status of the software and of the hardware, of course. And related with safety, we have a current transformer module that is very safe because you can remove the current transformer module and still the current is circulating that avoid the manipulation of currents in this kind of devices. That is really safe for the operators. What are the main functions related with the fault recording applications in the 7key85? The 7key85 is a fault recorder and is the main function, I will say, of the 7key85. Then we have different recorders. We have the fast scan recorder. We have the slow scan recorder. We can have up to 2 slow scan recorders. We have continuous recorder, trend recorder. We can have up to 5 continuous recorder and up to 2 trend recorders working in parallel. These continuous recorder and trend recorder are mainly for power quality topics. Sequence of event recorder. Related with the fault recorded application, we can have all the events related with the power system fault. That means we can bring to the device using binary inputs, for example, the trip of one protection device, for example, distance protection, overcurrent protection, and the position of the circuit breakers. You can fit this information using binary inputs or also using 6150 GUS. The different sample rates that we have in our device. You can set up the sample rate of the device. The maximum is 16 kilohertz. That is really quite good because it's the one that the voltage transformers and the current transformers can support. Some other applications offer more, 20 kilohertz, but then the current transformers and the voltage transformers are going not to give this kind of a filter, I will say. The ring buffer that we have in the 7key85 is for 15 gigabytes, and then you can split for the different fault recorders. And we have the power quality recorders that Marcus will explain later on. From the point of view of fault recorder, we have the fast scan recorder. When you have a trip in your installation, then the fault recorder is going to storage the information in his memory and is going to save the fault record. In formats like ComTrade, for example, then you can evaluate this in SIGRA. And here I have some examples from SIGRA where you can see the different sync waves for the different phases, and you can do a deep evaluation in SIGRA. Here you can see that I'm doing a zoom in SIGRA, and I'm doing a deep inside of the sync wave. You can see here that I have a fault recorder of 16 kilohertz, and you will see here, if I go deep, that there is sample rate of 256 samples per second in a signal of 60 hertz, and then you will see the samples here. If it's 50 hertz, you are going to have 320 samples per second, per cycle, sorry. Then you will see here in SIGRA. And SIGRA is a powerful tool that permits us to evaluate really in deep the protection topics. Also in the 7 key 85, we have the slow scan recorder. If you remember before, I saw the fast scan recorder that is really for transient events that we have in our system, like trips of the distance protection or the line differential protection. With the slow scan recorder, we evaluate slow events. What kind of events? We evaluate, for example, power swings or topics related with frequency. And then we can evaluate the different phenomena in our power system. The advantage of the slow scan recorder is that you can have a long recorded, at least 90 minutes, and the device is going to save the RMS values. You can set up the device to get a sample, for example, every half cycle. And then, as you see here, there are different samples for this record. Here also you can evaluate the slow scan recorder in SIGRA and do a small fast evaluation of the phenomenon in the system. Okay. These two recorders have the availability that you can trigger these 4 recorders. What is the meaning of trigger? That you can start saving the 4 record in the 7 key 85 based on measurements like voltage, like current, like frequency, like active power or reactive power, and then you can save the 4 record and evaluate the 4 record. How is going to work? If the frequency reach, for example, one value, then the 4 record is going to start doing the saving, for example, for the slow scan recorder. Also, there is the option to start the 4 recording using binary inputs or information coming from the communication system. Using, for example, 6150 GOOS, you can start the 4 recording application. That is the other way to start the 4 recording. And you can create also logics inside of the device to create the trigger of the application. This was related with the 4 recording application. The other topic that we have in the 7 key 85, it's related with the phasor measurement unit. We can update our devices, or we can deliver our devices with the phasor measurement unit functionality. What is the advantage to have the phasor measurement unit functionality here? The advantage is that you have all the monitoring functions basically in one device. You have the 4 recording application. You have the, for example, the weight area monitoring system with 7 key 85, and also you can have the power quality, all the monitoring functions in only one device. With the 7 key 85, we have the PMU according with C37118, that is the standard protocol to stream PMU data. In the stream of the PMU data, the device is going to send voltage, currents, with the advantage that the device is going to send the information of magnitude and also of the angles with high accurate time synchronization. And then you can compare the different values from different locations to enable the capability to improve the power system, the stability of the power system. You can do this, for example, with softwares like SIGARD. SIGARD PDP offer the option to evaluate power swings in your transmission system or in your power system. With the PMU, we have multicast communication. That means one PMU can send the data to different PDCs. And with our SIGARD, you have more than one phasor data concentrator. You have also the phasor data processor that collects all the information and do an analytics of your power system. One of the highlights that we have with the 7 key 85 now is that you can also receive the information from the process bus network. And then if the device, the 7 key 85, is connected to the process bus network, then you can stream also the data in C37118 to the upper level. And the other topic is that now we can also synchronize our PMU device with IEEE 1588. That means with a precision time protocol. And the other topic here, the device receives the information in sample values and stream the data in C37-180 protocol, but also this card, this Ethernet card, is also able to communicate in 6150 and send ghost message. That is another topic that is interesting, for example, for topics related with power system stability, where we can create special protection schemes or wide area protection schemes in the whole area to improve the system stability, all in the same Ethernet card. Okay, these are the highlights that we have related with the PMU application. Now, I'm going to give the word to my colleague Marcus Kraft, that is going to explain the power quality function. Then, Marcus, the stage is yours.
Yeah, thank you, Jose. Hello to everybody from my side. My name is Marcus Kraft. I'm technical promoter and expert for power quality analysis and evaluation system. In the next session, I will introduce you into the power quality functionality of the 7Key85. The current scenario is that the power quality recorders like CCAM Q200 or CCAM Q100 are providing their power quality conform measurements from the field level via IC 6150 to the CCAM BQS. On the right side, we have the 7Key85 as a digital fault recorder. Now we need to know that the BQ recorders are already designed and implemented to provide power quality conform measurement. Means conform to the IEC standard 61000-4-30. And we need to equip or to parameterize the 7Key85 to do this in the same way. The question comes up now, yeah, I know that the 7Key85 is already providing continuous recording. However, these continuous recording by default are not compatible for IEC 61000-4-30. To see the difference between the standard behavior of continuous recording and IEC conform recording, we can see here on the left-hand side, the continuous recording for power quality is based on so-called 10-cycle measurement. 10 cycle in 50 Hertz means 10 times 20 milliseconds. Then we speak about a sampling interval of 200 milliseconds. And these 200 milliseconds will be aggregated afterwards up to 10 seconds for the frequency, 10 minutes for all voltage-related characteristics, and in 2 hours for the PLT, the long-term flicker. Here are the characteristics which have been relevant or need to be considered inside a power quality grid code. And side by side to this continuous recording, we have also event recording equipped inside the 7Key85. This is based on half cycle, on 10 milliseconds. This we need to detect dips, swells, and interruptions. Because also dips, swells, and interruptions are phenomena which needs to be considered for power quality. The magic word on this slide here is 10 cycles. Side by side to the already introduced fast scan recording mechanism and slow scan recording mechanism done by Jose, for power quality is relevant the so-called continuous recorder. The continuous recorder is, like the name already saying, a continuous recording mechanism. And here we can configure or parameterize so-called average values or the averaging time. Second, we need a trend recorder, and this trend recorder has a task to fetch all the signals which are related to voltage events, dip, swell, interruptions, as well for the flicker, the PLT, the long-term flicker. And last but not least, it's not a recorder, it's a functionality. PQR is a function inside the 7Key85 to equip the device IEC 61000-4-30 conform power quality measurement. So before I will show you this in practice with a Dixie configuration user interface, I would like to give you an overview about the essential 4 steps, what needs to be done. The first one is we have to add a second continuous recorder. One continuous recorder is already on board. This we will parameterize to 600 seconds. This means 10 minutes for the voltage-related characteristics. And this second one, this additionally one, we will parameterize for 10 seconds because task of this recorder will be to measure the frequency. We need to add a trend recorder to fetch all the event-related signals. Then we will expand the information routing by so-called PQ function blocks. The PQ 10 cycles for 50, 12 for 60 Hertz cares about the 200 milliseconds aggregation for the voltage-related characteristics. The function block PQ 10 cycle harmonics, what the name is saying, cares about the harmonics and the THD, the total harmonic distortion. The function block PQ flicker cares about the flicker aggregation, and the PQ trend is responsible for all event-related measurement. So when these function blocks are added, then we can go forward and route the voltage frequency unbalanced flicker THD, which was recorded by these function blocks. There we have to assign it to the dedicated recorders. All right, I will switch now to my Dixie application and will do these 4 steps with you together. So here we have a Dixie application running inside a virtual machine, and I have here added a new 7 key 85. There is nothing parameterized till now. And our task now is to equip this device to make it conform to IC 61000-4-30 recording. The first step is we have to add in the chapter recorder one more additionally continuous recorder. This can be done on opening the global Dixie library, select in types the 7 key 85 Ford recorder, scroll down to the chapter recorder, and here are the continuous recorder. We drag and drop this recorder in the section of recorder. Now it appears here. Now we have continuous 1 and 2. We said that one recorder will be used for the 10-minute average values and another one for the 10 seconds. To make it clear that this cannot be somehow misinterpreted, let me rename it cont average 10 minutes. And the second one, cont average for 10 seconds. So we may not forget to parameterize the device to make it compatible for this measurement. The 10-minute is by default on 600 seconds, but the second continuous recorder, we have to switch from the default value down to 10 seconds. All right. One more recorder is necessary. We have to add also a trend recorder to our recorder repository here on the left. For the trend, no parameterization is necessary, but let us rename all of these trend recorder to make it clear. Okay, trend PQ. Good. In the section of voltage current 3-phase, this function group, here all the triggers are parameterized. We will not touch these triggers. We keep it like it is. So only one what we have to check here inside is that on this function group, that's a rated voltage is absolutely correct with a real measurement, with a real declared voltage in the field, because from power quality will calculate all kind of deviations based on this value, which is given here in the rated voltage. When we are metering in 11 kV network, then we have to give here 11 kV. Okay, so the next step is we will go inside the information routing matrix. Let me move out these 3 on the left to have more space. We open the function group voltage current 3-phase. the recorder routing, and these are the default recording or metering mechanism. This we may not use because they are not power quality conform. Here we have to add now the so-called function blocks for power quality 10 cycle. Drag and drop it here. Here we are. We need the PQ10 cycle for metering the harmonics and the THT. Drag and drop it here. Needs to refresh. The next one, what we need is the PQ flicker to measure our long-term flicker power quality conform, and the PQ trend. So, all right. So now we have here on the left-hand side our power quality conform measurement. And let me rearrange Dixie a little bit. And we have here on the top our power quality conform recorders. The continuous for 10 minutes, the continuous recorder for the 10 seconds average values, and our PQ trend. What we now need to do, we now need to route information which are recorded by these function groups, function blocks, to the dedicated recorder. Let me open the PQ10 cycle. Here we will catch the phases A, B, and C and map it to the continuous 10-minute average values. Phase A, phase B, and phase C. We catch here the frequency and map it to the 10 seconds average recorder. Because grid code conforms, the frequency needs to be aggregated to 10 seconds average values. One more needs to be done. Also, the unsymmetry or asymmetry needs to be routed to the 10-minute recorder. And now we are finished with a PQ10 cycle block. Let us forward with the PQ trend. In the PQ trend, we will catch also the phases and map it to the trend PQ recorder here. Here you can see the advantage on gives the recorders a good name. Then everything is clear. There are no misunderstanding to route information to a wrong recorder. Yeah. So next is the PQ10 cycle for harmonics. Here we will fetch also the phases to the 10-minute recorder. Phase A, phase B, phase C. Then we have to choose the THT, total harmonic distortion, also to the continuous 10-minute recorder. So, and last but not least, the PQ flicker. Here not the PST, we need the PLT, the long-term flicker is considered in the grid code. These we have to route to the trend PQ. So that's all. We have now on the left-hand side our power quality conform measurement aggregation, and here on the top, a grid code conform recording mechanism. Let me now switch back to the presentation. All right. So next step will be we load this configuration, what we have done to the device. After that, we can export the IID file, the device description files from Dixie, and import these into the CCAM PQS system on the IEC 6150 protocol. Afterwards, we are assigning the device to a topology node and assign also to the topology node a grid code. That's it. So from now on, our 7key85 here on the right-hand side is metering grid code conform. So the summary of the benefits are we don't need to change hardware. This is very essential. This means when we equip afterwards and 7key85 is power quality, we have to do only parameterization changes. We need per measuring point 150 function points. Now, this is necessary for the additional econ recorder, for the trend recorder, and for these PQ function blocks. And from now on, we have an IEC 61000-4-30 conform measurement implemented in the 7-key 85. That's all for now. Let me now switch back to Jose to proceed with the process bus topic. Thank you very much.
Thanks, Marcus. Now that we have configured our 7-key 85 with power quality applications, now let's go to see how we can integrate our 7-key 85 in a digital station using process bus. Here we have a process bus overview. This is a slide that shows how we can bring the information from the process to the level of the control system. Here we have the process bus network, where we can collect information from the current transformers and from the voltage transformers using a merging unit. This merging unit can collect information from conventional CTs or conventional BTs and give us the information in 6150-9-2. That means convert the analog signals in a digital signal that we can use here in any of the IDs that we have. One of the IDs that we can have here in the station is, of course, the fault recorder. The other way to collect information also from the field is using merging units for LPITs, non-conventional instrument transformers. And when we can also bring here the information to the fault recorder. Or also we can collect the information using the conventional way, that is just we can wire the current transformer and the voltage transformer to the protection relay or to the fault recorder. This is the process level. Then we have the station level, where we send the information to the other systems that we have in the station application, like substation automation, human-machine interface, or power quality tools that we need to do in order to evaluate the power quality, like SICAM PQS, for example, that we have in our portfolio to do the evaluation of the power quality. Okay, this is the structure of process bus overview. What are the benefits of the process bus? We can reduce the size of the station. For example, the GIS could be smaller because we can have small CTs and small BTs. For example, if we use not conventional instrument transformers, then we can have a small room for the GIS. Okay, that's one of the topics. The other topic is related with safety for the operators, because now that the analog signals are digital, then it's not needed anymore to manipulate the current circuits, for example, that we need to manipulate, for example, to test one protection device or to test our fault recorder. This is related with the primary equipment. With the merging unit, basically the merging unit is going to help us to save costs related with Cooper, because now that the merging unit is close here to the process, then the only thing that we need if we have conventional CTs is to wire the CTs, the BTs, and the binary inputs to this merging unit that is really close to the primary equipment, and then we send information via process bus to the relays or to the fault recorder, for example. Then we are going to save Cooper, basically. The other topic is that we use 6150, and our merging unit is interoperable with any other vendors. Okay. Once that we have the process bus implementation, what are the benefits? Basically, reduce space in the control rooms. That is going to save money in the implementation of the digital station. our devices are flexible and scalable, and then we can adapt our devices for future requirements. That is, let's go to say these are the benefits that we have with the process bus application. Some topics related with the process bus that are important, for example, for us in the power quality and for the fault recording. What kind of streams can our merging unit handle? Our merging unit can handle different kind of streams in different ways. We have in our merging unit the possibility to have more than one Ethernet card and send, for example, with one Ethernet card, one stream with 14 kilohertz, for example, just for the power quality and fault recording application, and another stream, for example, with 4.8 kilohertz for another application, for example, for a protection application. That means we can also use our merging unit for the protection application and with another card for the fault recording application. This is one of the advantages. Or we can have in only one card also two streams. One stream for the protection application and another stream for the fault recording and for the poor quality application. As I show here, in one Ethernet card, we have two streams, or here we can have two different networks, one for the protection application and another one for the fault recording and power quality application. This is one of the flexibilities that we can offer with our portfolio related with the merging units. What kind of topologies, of network topologies we can build with our merging units and our 7key85? That means we support the redundancy protocols like PRP, HSR, and then we can build this kind of networks with our 7key85 also. That means here, if we want to have redundancy also in the network topology, we can create PRP. Here in the example, I have also a line connection, because if we have an application related with fault recording, usually the redundancy is not quite important. But if this is embedded in the digital station world, then our merging unit also support PRP, and also our 7key support PRP. And then we can have here the master clock to synchronize the samples. The other topology that we support, or that our device support, is HSR. It's a ring topology, and we can connect here, for example, up to 5 devices in the ring. That means 4 merging units and one 7key85, and have a ring, and synchronize our devices using IDP or PPS, whatever it is. That is the other topology that we support. And now, in the next minutes, I'm going to explain how to configure the process bus in our 7key85. I'm going to explain basically to configure 4 merging units and how to connect these 4 merging units to the 7key85. Okay, I'm going to show in the next slides how to do that. Okay, 7key with process bus that I'm going to show. The first thing that we need to do is we need to create the devices here. Then we need to create our device 7key85. And then we need to create our device, the merging unit. The merging unit is the 6MU85, okay? The first topic that we need to do, I'm going to configure the server. The server in my case is the merging unit. The merging unit is going to send information to the 7key85. The first topic that I'm going to do is I'm going to go to this menu, device information, and in device information, I'm going to change the name of the device and the IC6150 name, okay? The second topic, and that is really important, is that our relays and our ID support 6150 edition 2.1. With that, related with applications for time synchronization, our devices can work with local synchronization. Without local synchronization, the device can still synchronize the samples. That is really important if we use edition 2.1. The next topic that we need to use is to configure here in the hardware and protocols the Ethernet module. Okay. In the Ethernet module, here we configure the IP of the device. That is the first topic. The second topic here, we move to the communication. And in the communication, we select the protocols that we are going to use in our merging unit. Then the first protocol that we need to select is 61850-A-1 that permits the merging unit to use goose applications. That means we are going to connect our merging unit with the 7 key, and we are going to send goose from the merging unit to the 7 key, for example, to start the fast scan recorder or to start the slow scan recorder. The second one that we need to configure is the merging unit application, that is 6150-9-2 merging unit. Okay, we configure these two protocols in the communication application. The next one is the redundancy. As I told you before, our device supports different redundancy protocols. We recommend always for process bus topics seamless redundancy like PRP or HSR. But in this case, if you are using just for recording application, you also can use line mode, okay? And then you need to select here in network. That means we move from redundancy, then move to the network, and in the network, we select the time synchronization that we want to use. If we want to use IEEE 1588, then we select the IEEE 1588 protocol. Okay, one of the topics that we have in our device is that we support the two versions of PTP, 61850-9-3 and C37.238. That means the power profile and the utility profile. Both profiles we support in our device. Okay. Then we go to the merging unit, and still we continue with the measuring point routing. In the measuring point routing, we select, for example, the name of the measuring point that we want to connect. For example, I select here Bay1 for the current measurement and also for the voltage measurement. Okay. Then I go to the merging unit routing, and in the merging unit routing, I select these two measuring points that I'm going to send these two measuring points to the process bus network. Here, there is one topic that is important, is the kind of stream that I'm going to use. The advantage of our process bus concept is that we can use flexible streams. Here, you can select the flexible streams. You can also use like edition streams if, for example, the device that you are going to use is not compatible with flexible streams. But one of the topics that we offer is that we have flexible streams in our portfolio. And here, one important topic is that we select the sample rate that we need for our application in for record or in power quality. Then, for example, we select 14 kilohertz or 15 kilohertz. That is the frequency that we are going to use to stream the data to our client. Okay. Now that we have done the configuration of the merging unit, we are going to do the configuration of the fault recorder. We start with the same procedure. Basically, we start with the device information. We give the name to the device. We give the name to the 6150 name to the fault recorder, and also we select the edition of the 6150. Remember, we have edition 2.1. It's one of the topics. Here you can see that our recorder has the fast scan, the slow scan, continuous recorder, and trend. Remember, as we saw before, we have different recorders, and you can configure these recorders also after you finish your configuration with the process bus. Then we move from the device information, we move to hardware and protocols. And in hardware and protocols, we do the same as we did before. We select, we give first the IP address, then we select the communication protocols. But in this case, because we are in the 7key85, we select a 6150-9-2 client. That means that we are going to receive information from the merging unit. In this case, the 7 key is going to receive information from the client. Also, we select the redundancy, for example, line mode or HSR or PLP, whatever we need. Then we select the 1588 protocol for time synchronization. And here we can select the kind of settings for the client, okay? If the device is able to accept time synchronization that has not a global synchronization. That means if we can use local synchronization for our device. And also the kind of profile that we require for the time synchronization. If we are going to use a power profile or utility profile. Now we need to inform also here in the measuring point routings that the 7key85 is going to receive the information from the merging units. Then here we select that this is a PV client and that we are going to receive the information from bay 1, bay 2, bay 3, bay 4 via process bus. Okay. And you will see here in the function group connections that the bays are going to receive the different measuring points here, bay 1, bay 2, bay 3, bay 4. We have still an error here because you see that there is an error that says that we need still to connect this in the system configurator. That is the next step, okay? Now let's go to link the merging unit with the fault recorder. Then we go to the 6150 stations here, also in Dixie. We add a new station. Once that we add the station, we add the devices to the network. We assign the devices, all the devices that we have, the merging units and the 7key85. And we create the station, okay? We save the station. It's an IC station, that is the SCD5, okay? We export the changes to the IC 6150 system configurator, and then in the system configurator, we do all the communication, okay? Once that we export the information to the system configurator, we are going to have the application system configurator where we can link the merging units with the fault record. You see here also the IP address of the different devices, and one important thing is that also we can estimate the bandwidth of the sample values and the goose bandwidth that we use or that our network is going to have. We have the network with the IP address, and here we have the sample values. In this icon, we select the sample values. Here we have the source catalog, and here we have the destination catalog, and we can connect the information from the source with the destination. Here you see the different devices. Here is the fault recorder, and here we have the merging units, okay? Then we are going to connect the fault recorder application with the merging unit application. Then we just drag and drop the information from here to here, and we can connect. You can do it phase by phase, or you can select the complete measuring point and drag and drop the complete measuring point, and the system is going to connect all together, okay? At the end, it looks like this one. You see, we have the connection from the merging unit to the fault recorder bay 1, okay? For the currents and for the voltage. I have done this one for all the bays, and then at the end, I export this one again. Sorry, I import this one in Dixie, import changes from IC 6150 system configurator. And then now our configuration is clean. And now the information is coming from the process bus client, okay? Okay, with this one, I've finished with the explanation about how to connect the merging units with the 7key85 to collect information from process bus or to bring information through process bus. What are the main benefits that we have with our 7key85? I will say you can save money because we have all the applications for monitoring in only one device. That is power quality, phasor measurement unit, and fault recorder. Our device is ready for digital station with process bus. Meets 6150-9-2, and as you see, it's also edition 2.1 of 6150. And also it's a device that is ready for a wide area protection application for special protection schemes in order to ensure the stability of the network. Okay. I want to say thanks for here our presentation. And now I give the stage to Micaela. Thanks, Micaela.
Thank you, Jose, and thank you, Marcos. That was definitely interesting stuff. And we had a lot of questions coming in. I have some questions on the list via the questions tool, and I've seen that some of them are already answered in the chat by Sasha. So thanks for your support there. We had some questions right in the beginning of the presentation, and I'm not sure if they are already answered with the presentation or if the shape of them is a little bit different. So I think I nevertheless start with those questions. And I give you a little warning, because I think we will not cover all the questions in this last remaining 5 minutes. So if your schedule allows for it, I'll take the question and answer round a little bit longer than this planned 1 hour we had with you. I think we will take about 5 or 10 more minutes. So if you need to fit to your schedule, it's okay to leave us, and you're nevertheless invited to stay for this question and answer round. So one of the really first question was, that's an interesting one for me too. What do you think about forecasting electrical faults in the future? And let's see whom of our experts tries to answer that or give a feeling on that.
Forecasting. Am I audible?
Yes, you are.
Yeah. Forecasting, let me interpret it in the following way. When a fault happens and your protection relay has tripped, then the fault already happened, yeah? But with the 7K85 as a fault recorder, you have the possibility to parameterize the limits inside the fault recorder for producing fault records or signals in a quite more sensible way. This means you can reduce the limits for trigger fault records quite closer or more sensible compared to the protection stuff. This means you will be more early informed about some anomalies in the network before the real fault happened.
Thank you. Yeah, that's one possibility. And it came to my mind that one direction here might also be something like predictive maintenance, where we talk about data collection and data interpretation. So yeah, stays interesting. Thanks for the question. And I'm not sure, SB, if your question has been answered already with the presentation, because you asked, when do you install a fault recorder? I think this when and where, Marcos, is probably something you deliver when you consult our customers with concepts, right?
Yeah, right. Yeah. Where to install fault recorders will be installed mostly on feeders to take a clear picture when a fault happened, to have a very detailed picture with 16 kilohertz sampling rate compared to the only 8 kilohertz from the protection relays. And you will get a complete picture of the fault. Yeah? Not only one device. Now with a 7K85, you can expand it up to 40 channels with expansion modules. And then you have an feeder overspanning picture about the fault, because all these channels will be covered inside the COMDRATE file. I mean, this is not enough. Then you can also trigger a second fault recorder via binary channels or goose signal to also start recording when one of the trigger limits are over or understepped.
The other topic here is important. In some countries, it's mandatory per regulation to install fault recorders. Then the customer prefer to have a system, an independent system, that is going to evaluate the performance of the protection system, and is handled by another department in the company that is going to evaluate the performance of this system. And that is the advantage of the fault recorder, that offers an independent view of the evaluation of the protection performance. Does not depend on the manufacturer of the protection device. The fault recorder is going to evaluate or is going to permit the customer to evaluate the power system faults. And in some countries, that is mandatory. Okay.
Thank you for jumping in there and amending it with more information. And the next question in the list, and I think, Sasha, you might help me. We already answered that probably in the chat. Do the 7KA85 support PRP and HSR simultaneously?
From my point of view, maybe Jose could correct me. This depends on the used number of communication modules. This is right?
Yes, that's right. You can have two independent communication cards, and in one card you can have PRP, and in another one you can have HSR. But in the same internet module, is independent. It's only one.
Okay, thank you for the clarification again there. So really valuable questions from you. And the next one seems to go in a similar direction. In case of usage of process bus and redundancy for this network, is it possible to manage GSE and SMV in the same time on both internet ports?
GSC. I don't know what is GSC. Such as you know, GSC.
Yes.
GSC is also not clear for me. What does it mean? Maybe we need to clarify this afterwards.
Yes.
Okay. Take it into a 101 discussion then.
Yes.
Thank you. And I think also the questions from HB, if it can record harmonics and supraharmonics, voltage and current, that has been in the chat. And if I remember it correctly, the answer was yes, right?
This is yes, but in the chat, the question was also with the supraharmonics. This is depends the number of harmonics which you like to measure. That means we are able to measure with the 7K85 harmonics and interharmonics up to the 50s of current and voltage. And if you are looking above this range, you should use another device type like the SICAM Q100.
I just see here that the colleague in the chat wrote that GSE is goose. Yes, our module is able to handle at the same time goose and sample values. That means the merging unit can have the two protocols, a goose and sample values at the same time. And we send over the same Ethernet card goose and sample values.
Thank you. And we jump into the question from NC, and NC wants to know how many analog and digital channels can be connected to a single 7KE85 unit, and how many 7KE85 units can be connected each other in order to have a complete fault recorder in a grid substation which have many bays, and what is the recording space capacity in gigabytes?
Okay, let me answer. A lot of questions. Hopefully I have understand this. Due to the fact that we have a modular system, we can start to have a device with 8 analog channels, typically for current and for voltage channels. But we can increase this device up to 40 analog channels in one central unit. That means we can serve there typically 20 current and 20 voltage channels. And if you have more feeders in your substation, then you need to have then another central unit to cover the rest. And that means if you have several devices in your substation, you can connect this to one system like SICAM PQS, which will collect automatically the data so you can evaluate them.
Thank you. That was quite a comprehensive answer. And I just come with the next question. I think it's in a similar direction, because SB wants to know how many fault recorders are required for a 400 kV substation with 4 auto transformers and 6 transmission lines.
Yeah, this is depend also on the number of the channels. That means when we are increasing more than 40 analog channels, what we like to connect to the device, then sure we need to use another one device or central unit. And I have forget to answer in the last question the topic of the memory. We are using a 16 gigabyte SD card as a memory to save all our how to say recordings. That means files of the recorders. That means of the slow scan, fast scan, continuous, and trench recorder on this memory. And this is a specific, you can say, format. This is SIPROTEC-5 format. This is a proprietary one, but nevertheless, these files could be also transferred via COMTRADE file from the fault records or as a PQDIF files from the continuous and trench recorders.
One comment more to this question just before about how many channels can be recorded for a typical substation. I think it depends also on the specification from the customer side. Yeah, if he wants to monitor a feeder with only current, or is it always necessary to measure on each feeder voltage and current? And depending on this requirement, we have to compose or configure or parameterize the amount of 7K85 devices with a dedicated expansion modules.
Okay. What's the benefit of fault recorders in manned 400 kV substation in developing countries? Maybe not only there, but what's the advantage of it? What's the benefit?
I think the main advantage is here that you have one device which covers different applications together. That means you do not need to have separate devices. You have typically fault recording and power quality in one device, and for other purposes you can use is for digital substation, and you can use it also as a synchrophaser and so on. And there you have also a big benefit, and also from the security point of view, you have also there a couple of things.
Okay, yeah, so seems to make sense to equip them. And then we have a question to the merging unit. Is this common in markets because grid operators are conservative and insist on cabling between CT and protection ID out of safety reasons? Is hardwire still recommended in parallel?
That means the technology shows that the performance with the process bus is quite good, I will say. The topic with the savings related with Cooper in high voltage station is height. That means if we have 500 kV stations in conventional wiring, the quantity of money that the customer is going to spend just to build the station, just to create the civil works and to do the wiring is huge. If you use process bus technology, then the Cooper, the reduction on Cooper is huge. The reduction in civil works also. The reduction in the control room. The control room is smaller. The number of panels is smaller. Then that means it's economical advantage in high voltage levels, and also from the point of view of safety, for the operators, because the operators now don't need to go to the protection devices to do the test and to inject the current in the terminal blocks. They can now test digital with some equipment devices. That means there are some advantages. There are some topics related with the traditions of the customer to use a Cooper, because they think that it's safer from the point of view of protection, from the protection point of view. But the technology permits to create some kind of redundancies that allows the system works perfectly in the digital station. That means, for me, it's an advantage to have a digital station.
Yeah, I fully understand. Safety, investment, reduction, and things like that. Thanks for explaining. Then we have a rather, it's not really off-topic question, but not only somehow related, but nevertheless interesting. It's a general question. Is it a must requirement to have a GPS clock in the digital substation, or can we use one particular time to all the devices within a substation without having a GPS clock? And in the bus bar relay, does it require a GPS clock for the process bus?
We require the GPS, there are different ways to do that. That means we can use, for example, PPS time synchronization. Is wire you wire the signal to the different devices. This is one. The other one is using the protocol itself, that is IEEE 1588, where you can spread the time signal to the different devices in the network. With the last version of the 6150-2-1 that we have, the advantage that we have now is that the devices can work with local synchronization. That means the master clock can synchronize all the devices without a global synchronization. That is one advantage that we have now in our portfolio. That means the process bus network can work without global synchronization, but needs a master clock device that is going to spread the time synchronization over the whole network.
Okay, I think that was almost the answer to the next question, because there was the question if the 7KE85 can function as a grandmaster clock in PTP to synchronize the merging unit or the network.
Not yet. We, we need to use an independent master clock.
Okay, thanks. And we have one last question where I'm not sure if we will be able to answer it right here, because it's what is the cost of 7KE85 for a 10 kV application? I'm not sure if we have a general answer to that.
No, we can just give them a direction, how to say. The topic is following. This is also depend on the configuration on the device. That means the number of channels. Then if you are using a display, which kind of display, which communication ports, if you're using function points and so on. But roundabout, this device types starts, how to say, with a central unit, roundabout with 6,000 to 7,000 euros. And goes up, but you are getting the price reduction if you extend the device with expansion modules. That means when you're using this, an example for 2 or 3 measuring points. And this is what we also see, that most customers are not doing this as an 8 analog channel device. Typically, they are using this for more, to cover more measuring points with one device.
Thank you. As expected, not too easy to explain. We have definitely some more questions in the row. We are not running out of questions, but we are running out of time. We try to get back to everybody's schedule. We will take your questions to the expert, and you will receive a mail, a direct mail with the answer to your question. So thank you out there for all your questions. That was a vivid discussion in the chat and some vivid and interesting questions out there. Thank you, Jose, Marcus, and Sasha, for your time there, for your explanation there. It was definitely interesting stuff to learn for me once again, and for the auditorium, I'm sure also, because that's why we have these constructive questions out there. The access to the recording and to the slides will be sent out to you participants, to everybody that registered for this webinar. In the upper right corner, you can find the profile sheet to download, to read some information again. I thank you very much for your participation. It was a pleasure for me to guide you through this webinar. We learned about SIPROTEC fault recording in the digital substation. Thanks for your questions to the experts. Thanks for your answers, my dear experts over there. And we learned about how to reduce a lot of hardware, reduce copper with a multifunction fault recording device, and how that can easily offer diverse applications. You've seen how this independent setting can provide additional network sensitivity, and how you can analyze faults and perform power quality analytics with just one device. I'm looking forward to meeting you soon in one of our next energy automation webinars. Looking forward to seeing more questions from you out there. So for me, it's time to say goodbye to you. Have a good day, and please contact us if you have more questions. Take care.